Say that one more time.
Put 2 square root of x in for y.
Because that would then give me this equation with one variable. Okay, so if I substitute this quantity in for this, could I then solve for x, which is equivalent to what we're doing here? Actually, we're looking at h and k. If I know h, then what? Using what?
Oh, that one up there. The x, y, is h.
Yeah, the circle of the, yeah, absolutely. So if I put in 1 and 2 for x and y, and I find out what h is by using the distance formula, I can then solve for k, and I needed the equation of the 2 circles. Would I have it then? Now you have to remember, you've got a plus or minus going on. So you've got a circle down here also to deal with. Now again, this is a problem that I could go ahead and finish it up. I've given you the pathway to it. I could go ahead and finish it up for you. But what fun would you have then? Okay? So this is a problem where I want you to go back. I want you to work this problem again. There's lots of little pieces. I'm going to post this on YouTube so you can go back and hear our discussion on it if you get lost. But I'm not going to finish it up for you. Okay? Because at this point, you got it. You've got it. Okay. Let's go on. If we're looking for vertical and horizontal tangent lines, let's just talk about this one. If I have a horizontal tangent line, it means the slope is what? So if I want to find the points at which the graph of the equation has a horizontal tangent line, I'm going to do what with the derivative? Set it equal to 0. Okay? If it's vertical, what do you know about the slope? And so I would then have to go back and decide what would make the derivative undefined. Now, it could be that the derivative is going to be a fraction. If it's a fraction, it's undefined when the denominator is 0, so I would look for making the denominator 0. Okay? So that, again, we have done enough implicit differentiation problems, don't you think? I've given you all of the hints I can on how to find those. Now it's just using those. And the hardest thing is finding the pathway to the solution. So I'm giving you the pathway. Okay? Take the derivative of this. Horizontal, set it equal to 0. Vertical, make it undefined. And chances are you're going to have a denominator, so you set the denominator equal to 0. That would make it undefined. Okay. Using logarithmic differentiation, the hint, first take the natural log of both sides. We'd have the natural log of y equals the natural log. I'm going to go ahead and make this to the 1/2 power. And if I take the derivative with respect to x of the natural log of y, now we just have to know what is the derivative of the natural log. Again, I can stop and ask you, what is the outside and the inside function here? And the outside function is? Let's start with the inside. Because again, if you're getting confused on this, I want you to always think, if I had a value given to me and I was told to find the natural log of y, what's the first thing I'd have to determine? Yeah. So the inside is y, the outside is the natural log. So what is the derivative for the natural log? 1 divided by, okay, so in this case 1 divided by y, then what? Well, we have that one that had all pieces. Let me just kind of give it to you. It's 1 divided by the natural log of the base of the logarithm, in this case the natural log of e. Well, what is the natural log of e? Oh yeah, this is the same thing as, the natural log of e is some value, and so this would be something to that exponent is equal to e, and what's the base of this? Well, it's e, so what is the exponent that gives you e? And it's just 1, okay, times the derivative with respect to x of what? I heard 1. I want to hear why. Yeah. Okay. Now that's using the entire rule, that the longest rule you can have for finding the derivative of a natural log. If you can do this on this problem, you can do it on the easier ones. Okay. Times the derivative with respect to x. I'm going to put this in brackets first because I got parentheses. We did one of these in the past. If you've got the, like the natural log of something to a power, that's equivalent to, so this would be equivalent to, remember 1/2 the natural log of the quotient? And what is the natural log of what is the log of a quotient? We could write it as the difference of 2 logs. You could go through that. Or you could say, well, let's see, I've got 1 divided by this times the natural log of the base. Let's just dispense with that if it's okay with you. It's just going to be, well, I'll put it down, but we really wouldn't have to. Times the derivative of this. Now, this is another composite function. This inside here. So you've got 1/2 this quantity to the negative 1/2 times the derivative with respect to x of that quantity. X squared minus 2 divided by x squared plus 2. This now is going to require you to use what? Quotient. Yeah, so you've got a couple of things to do here. So, this is your x squared minus 2, x squared plus 2. If you took the logarithm and you wrote now this is 1/2 natural log of x squared minus 2 minus the natural log of x squared plus 2, you would be maybe a little easier to find the logarithm of it. But this whole thing says use logarithmic differentiation. Now, do you have to use that for this problem? Could we have worked it without going into all the logarithm stuff? Yeah, we could. We could. And it would be one of the simple problems from what section? 3.4, our chain rule, our composite function? When it says to do it. Okay, that's an awful answer. I don't have a specific example in mind, but there are certain problems in your future with calculus or in physics or whatever where taking the natural log of both sides might help you solve the problem in another aspect of it later on. Because later on you need to maybe use a natural log for something. So then it would be, to be honest, and right now what we're doing, whenever it tells you to do that, and again, that's the worst answer I can give you. But it's right now the truest one. Okay, so let's go on. This is a good problem because of the terms orthogonal. I don't know if you studied orthogonal graphs in geometry or someplace. So the note is 2 graphs are orthogonal if at their points of intersection their tangent lines are perpendicular. Two graphs are orthogonal. Okay, so now how we know is that their tangent lines are perpendicular. So if I have, let's see if I don't even have a picture of this. If I had the graph of this one and the graph of this one, and I found out that the tangent to this graph is perpendicular to the tangent at this graph at a point, then I'd say the 2 graphs are orthogonal. Okay, to hold you responsible for this? Am I going to ask you to memorize what orthogonal graphs are? No, I'm not going to. I will ask you, though, to understand that if I give you this, you know what to do. So let's get the roadmap out. What's the first thing I'd want to do? Yeah. Take the derivatives of each equation. Could we write these as explicit? Could each of these be written as explicit? Yeah, I could say y equals plus or minus the square root of x cubed, and over here I could do that. So yeah, I could, but then it'd be plus or minus, and so these by how we see these are not functions. Okay, so take the derivatives of each, and then do what? Well, let's do that. This is a good problem. So let's say take the derivative. Let's start with x squared equals x, or y squared equals x cubed. We would have 2y. I'm starting with this one. Now I should probably do it right. I asked you to do. So this would be 2y dy dx equals 3x squared. So its derivative is 3x squared divided by 2y. So over here with this one, let's see, this would be taking the derivative of each term. So I do that plus 6y and then dy dx. Yeah, I took the outside function, and then the derivative of the inside equals 0. Okay, so down here, dy dx is equal to negative 4x divided by 6y. Or we could say negative 2x divided by 3y. Those are slopes, equations to find slopes of lines tangent to each of those curves. Now, it says that the tangents are perpendicular. So what do you know about this derivative and this derivative? They are, how do slopes of perpendiculars relate? Negative reciprocals. Okay, so 3x squared to y is the same thing as negative 1 divided by negative 2x 3y. So that would be, well, let's just say negative 3y divided by negative 2x. Let's see, that would be negative 6, let's dispense with the negatives. So that would be 6x cubed equals 6y squared, or x cubed equals y squared. I'm right back to where I started, aren't I? Look at that.